Good morning, this is Cody Henderson. Today we're going to look at how you can use a GUI in Eclipse. We're going to use WindowBuilder as the tool, and we'll go over the steps you can actually do to make the code to make this do something amazing and fun. So here we have an example of the GUI we're going to make. As you can see, it's pretty simple. We just have a button, a label, and a pop-up that comes inside it. We'll go ahead and take a look at the code that happens to make this work, but as you can see, this is what we're going to be going for as we make the actual project. So follow along, we'll see what kind of cool stuff we can make. First thing you want to do is, of course, make your Java project. We have our project structure. We have a GUI.controller and a GUI.view packages. Inside the controller package, we have our runner and our controller classes. And inside our view package, we have the SampleFrame and SamplePanel classes. As you can see right here on the right, we have the exact screen from the package explorer that we can see right there. So as you can see, everything's inside the source folder. And we have that lovely little packages that organize those pieces. This project is really basic, so there's no model package. But if we did have a model package, it would be just GUI.model. It would have the references of things we're actually working with inside this. But again, we're using the lowercase package structure we always do, and using that to organize the code so we can have that model view controller architecture built into what we're working with as we go along. So here we go, and we'll take a look at the runner. The runner is the most basic piece of code as always. We're going to use the same exact runner we've been using in all of our projects. There's no change literally for what we're doing. So we just have our public static void main, we make an instance of our controller, and call the start method. It looks just like we've been using the entire year. So again, just pretty basic, easy to go. We then have our app controller. The first thing we're going to take a look at is the constructor part. And so we have inside our import section, we have an import, a reference to the frame class, and then a data member name frame so we can actually talk to it inside our project. Our constructor itself, pretty basic. We have a controller with no an app controller constructor with no parameters. We set the count variable to be 0 because we always initialize every data member. It doesn't matter if it has a value or not, but 0 is a great number for this one because it's how many times something's been clicked on this. And this top frame is a new sample frame, and we're using a this parameter when we initialize the sample frame. Now, when we're using the this parameter as a sample frame, so we can send a reference to the existing object because we have a singleton pattern we're using with this. There's only one controller in the entire app, and so we're using that singleton pattern so we can actually go through and keep a single reference to what we're doing and have some great stuff with that. And so that's what we're going to be able to, so we can send references back or information back and forth between our GUI and the controller that's responsible for doing the management of the sending information back and forth on the screen. And that's how we're going to work with that. Our app controller methods we're going to be using, so these are the methods that exist inside the app controller. These are the basic ones you're going to have for all of your projects. The first one, of course, is the start method. In this case, I'm just using a JOption pane to show a message saying, hey, the app is loaded. And notice that inside the first parameter, we're putting a reference to the frame data member. That frame data member is so we can actually have the pop-up be centered right inside the actual frame itself, rather than being wherever the screen happens to be. So that makes it really nice for organizing the actual GUI itself. We have getters and setters for any data members that a controller needs to have access to publicly. And this is where, of course, in this case, we just have our get count and update count methods because that's where the controller is responsible simply for just maintaining a count variable. No big deal. And then we have, of course, our frame getter. We don't need a setter for this because we're not going to replace the frame at all. We're never changing that variable, so no setter would be required whatsoever. But we want to have access to the frame, and this is so we can, and any other class that needs to get a reference to the frame, can center any pop-ups or anything inside that centeredly, nice little orientation for us. So that's where that's going to happen. Okay, SampleFrame. Now, we've talked about the frame package before in class and some other lectures. The frame class is almost like the main. Once you make your frame, you never change it. The sample frame class is the same kind of thing. A JFrame subclass is really #basic. We're not going to change a lot. It's pretty standard. It's almost as standard as the runner class, where it's just going to be the exact same code every single time. So as you can see right here in the package structure in the header, we have a package where we always, of course, reference the package the class goes in. We have a couple imports we have to have. We have the JFrame class, so we can import our parent class's structure, and a reference to the controller because we have to know what we're talking to. Now, we have inside our class header, we have the extends keyword to show the Java inheritance. We'll be talking quite a lot about inheritance over the next few weeks, so keep watching on that so you can actually go for what that means and how we actually use that. For data members inside our frame class, we only have two. We have a reference to the app controller itself, so we can have a reference to it in case we want to do any advanced programming. We're not using it inside the actual project right here, but again, if we want to do forward thinking, we want to make sure, hey, if I want to do something cool and amazing, we want to have a reference to it in here as we can use with it. And then, of course, we have a reference to the panel that we're going to be owning inside the screen. Now, if you have a complex GUI, you have multiple panels. This is a simple one, so it's just one panel. But your frame owns the panels, not the controller, just the frame. Because again, we want to have that division of powers when we're talking model view controller, so that the ownership of the code and the ownership of the things that we're working with is in the simplest possible packages structure. And so in this case, we have the controller has a reference to the frame, and the frame then has references to any of the panels that exist inside it. And that's how we're going to organize the code so we can make that work. So we'll go ahead and go look with that. First thing we have is our constructor. In our constructor, of course, as you can see, we have a reference to the AppController parameter, and that was what we sent as a this callback previously when we instantiated it in the constructor of the sample, As you can see right here inside SampleFrame, we have a reference to the AppController as a parameter, and that's what we called with the this parameter back when we instantiated the SampleFrame instance in the controller class. And so we have to have that reference right there. So of course the first line, because this class extends JFrame, when we're doing any class that's a subclass of something, explicit we should call super as the first line of code. Now super with no parameters is included automatically by default in Java, but we're not going to do that. We want to have good practice, and so we always have the super call explicitly listed right there. Then, of course, we need to initialize any of our parameters that are passed through. And so this app equals app. Great little initialization there. And then we initialize all of our data members. In this case, we just have a single panel, so we initialize it. This.panel is a new sample panel. And again, we're passing a reference to that data member that we just passed in. And because I initialize my data member, I have a reference I can send through it by passing it this.app. Then I call a reference to my helper method, setupFrame, which is really important because a frame has some specific components you need to set up before we go through. So let's go ahead and take a look at that. Here we have the SampleFrame setupFrame helper method, and this is what we use to actually organize our frames so we can actually do this. Now, like I said earlier, the SampleFrame or the JFrame subclass is basically the same every single time. The only things you're going to have to change are some minor details that we have right here. So the first thing we have to do inside our setupFrame helper method is we install the pane that we have as our data member inside the JFrame itself. So that's what the setContentPane method call does. Then we have the properties we want to set. The default titles I think you should always set are title, size, and whether or not you want it resizable. Title, give it a good title. You want to have a window that makes sense. You can actually see what you're running with. The size, make it big enough to make sense. You want to do it. And if it's resizable, now this is a question of what do you want inside the app. Now we're using this is going to be resizable true for this example right here because I want to demonstrate how the Spring layout works. But once you decide your GUI and how you want it to be set up, that might not be the case. And so this is something you want to actually take in mind whether or not you want to have that be something you can resize or not. But that's something to practice with and play. It depends on the app. Take a look at what you're doing. However, the key, the most important thing, it's outlined there in red, has nice big red writing right over there, and also over here over on the screen, make it visible. If you do not make a JFrame subclass instance visible, it shuts down. Just gone. So, yeah, we have to do it. Make it visible. That needs to also be by the rules of the way the JVM runs the code. That has to be the last line after any GUI component manipulation happens. So have that be the last line of your setup frame because that's where it needs to be done so it can actually be effective and work. So last line of your setup frame needs to be a call to set visible true. That's key. We're good. Now, the next class we have is our SamplePanel class. Now, the SamplePanel class is where we're going to be doing all the work because the JPanel subclass is actually where all the GUI stuff happens. And so there's a whole bunch of stuff we have to handle with this. And so we're going to take a look at that right here. So in the import section, we've got a giant pile of them. I know there's a bunch. I know it's a lot, but we're not using the dot asterisk because I actually want to show what we're working with, and so you can see what happens inside there. And especially want to see the fact that the dot asterisk only takes one level deep. And especially in the more advanced projects, one level deep does not cut it. And even when we're doing anything with working with the action event and action listener, those are 2 levels deep. So I can't just do java.awt.event. That's not enough. I have to go to the action listener and the action event components specifically inside that anyway. We also have to have an import for the controller. And personally, one of the things I like to do, as you can see right here, I grouped all those imports based on the functionality we're working with. And so as we go through and get those more involved, more complex structures, you might want to do some other types of groupings for that. But especially when you're first working out and how to make sure you have the right pieces, I definitely recommend that you use grouping on this. Also, another word of advice, never, ever, ever let Eclipse auto-fix things for you. Eclipse is not as smart as a human. It grabs the first thing it thinks might compile. And there's lots of things named the same stuff, so don't do it. Yeah, I know, crazy. All right, SamplePanel. The next thing on SamplePanel we have are the data members. These are things that we're actually using inside our panel itself. Now, this is a really basic, simple panel, so we don't have a lot of data members, but we have that right there. In our class header, we also have the fact we have the extends keyword because JPanel, because again, this is a JPanel subclass, so we have to have that reference right there. Inside our data member, we have our app parameters, so we can actually send messages back to our controller because, again, we have that model view controller architecture that we're using throughout all of our projects, and so that's how we maintain that structure with this. We then have our GUI components of a Spring layout, a JButton, and a JLabel, and so that's where we're going to have that happen. Now, in a more complex thing, I'd actually have those separated out based on either functionality or type because I want to make sure, oh, here's all the stuff for this action, here's all the stuff for that action, and group those all together. In this really quick, simple thing, it's just all GUI together. And then we have a standard string because that way way, if I want to make any changes to something, or if I want to maintain a default value inside a button, label, etc., I have a string data member that I can use to assign that easily. Makes it really nice. So that's where we're going to go for this. Now, we have a stub example right here inside the sample panel, so we can talk about the structure of the constructor. As you can see right here, order is important. When we're talking constructors, we really need to build things in the right order. So again, of course, on the constructor, we have our data member. Again, our constructor right here, we have our parameter of an AppController. That has to be the first thing. We don't want to have a default constructor or no parameters constructor when we're talking about our JPanel subclass or a JFrame subclass, because we need to send the reference to the controller to it. So we always have to have a parameter right there. The structure right here, we have our subclass. The first line is a call to super. Then we have our assign all our parameters. There's only one right now, so we make sure we assign that one parameter. Then we initialize the data members, of course, and finally our helper methods. Helper methods really make life easy. Otherwise, our constructor would be this tall, and that's going to be yucky. We want to keep our constructor as simple and as easy as possible, so let's take a look at that. So here's the constructor after we fill in the associated code that goes alongside that. So of course we have our same parameter. First line, of course, is going to be a call to super. You have to do that first. We want to make sure that we get that super call in and make sure that's aligned. Then we assign our data member, so this dot app equals app. Again, I'm using this dot to reference the one that belongs to the object, and the green app belongs to the parameter. So I assign it with a parameter into the object. We're good to go with that. Initialize all the data members, and so we want to make sure I do the text first, because that way I can use the text inside other parameters and have that be available right there. And so this .appLayout is new spring layout, then the JButton, and then the sample label, have those right there. And I want to make sure I call all my helper methods. Now the order of the helper methods does matter. So setupPanel first, then take care of the layout, then take care of the listeners. So first thing we do is we make sure we put the pieces in the structure, then we do it with the layout of the structure, and finally we make sure the structure does stuff. That's what we're going for, and that's what we're going to work with. So the first thing, again, is the setupPanel helper method. This is what's in charge of loading the GUI in there. So we have the layout manager. If we don't create a spring layout or other type of layout manager, our default is flow layout. And nasty. I'll give you a demo when we take a look at that in a minute, but we are always going to be using spring layout in class, because that allows us to get a nice little amount of springiness. We can make things fit and squish, and we can control the space in between things. We can do a lot of good stuff with that. We want to define our color as well. It's very, very, very important, because, hey, color is amazing and magenta is pretty. So, hey, let's do it. We also make sure we add all our GUI components to the panel's hierarchy. And I say hierarchy explicitly because the panel holds stuff, but we can put things inside of things as well. And so when we add stuff to panel's hierarchy, it's really key that if we have something that's a container file, we put the container in and not the pieces. Otherwise, there's a conflict. It gets unhappy. It doesn't work, and everyone's sad. And we don't want sadness with this. We want cool, happy things. So we're going to go ahead and do that. So make sure you add things to it in the right order with that. Go ahead and I just put them in this.add, this.add, this.add. And again, because it's a subclass, even though I didn't write the this.add method, it exists because I have access to all my parent class's methods. Good times. We love inheritance. Okay, so the next one we have is a setupLayout helper method. Now, the setupLayout helper method is a dumping ground. You do not write the code here. As you can see in this top picture right here, when I use the WindowBuilder tool, which we'll be talking about, it literally just throws the code the first place it will compile, and most of the time, it's in random lines inside the constructor. Yuck. I know, it's nasty. We don't want to have that. We want to get that sad kitty away. And so what we do is we take all those lines out, and order, in this case, order does not matter. We just take any line that starts with AppLayout.putConstraint, and we put that inside our setupLayout helper method. And we just dump that every time. So once you make your WindowBuilder GUI stuff, layout stuff, get it all arranged, take all the code that's from there, put it inside the setupLayout method, and we're good to go. And so I recommend, like I have said before, do all the layout stuff first, and then after you get everything put together, and close it, leave it alone. Don't worry about it, because again, this is not a user interface course, but this is where you can practice and get stuff taken care of and get that organized really fast. But if it has the line starting with AppLayout.putConstraint, it goes inside the setupLayout helper method. Make sure you practice that. It makes life a lot happier. The next method we have is a setupListeners. Now, this is where the really cool user interface work happens. So we have a listener. It's a thing that's always active. It's listening. Yes, I know my big ears are going to show off with that. But a listener is listening for some action to occur. And the listeners for this case are just a button one. What we do is we attach each listener to one object. It makes it so we can have our class a little bit cleaner, more organized. It's really important we check our spelling, because the action perform method should you call a refactored method. We want to make sure we use that right there. As we can see over here on the right-hand side of the picture, we have our anonymous instance being created right there with a new action listener. You need to make sure you use the action performed method, and then our parameter name, in this case click, it makes sense because I'm clicking a button, but it's a formal parameter so the name doesn't matter, and most of the time we don't even use it. It's just to make sure that we know what we're working with. As you can see on the layout of the actual method itself right here, we have our vertical alignment squiggles, we have a sample but not action listener, and then an open parens, and then right here, we have the vertical alignment squiggles. Let me get my cursor right here. So we have our vertical alignment squiggles right here, followed by a closed parens and a semicolon, because this is actually one single giant line. But what I'm doing is making an anonymous instance of a class that I can use inside this, and it's really helpful. And so we want to make sure when our action perform method that we use a refactored pile of code, because it makes life for debugging a lot easier. We can make sure that we have a method happen and check that. It makes looking inside this a lot nicer. Trust me, we'll see this when we do debugging later on in GUI, but it really makes life a lot happier when we do debugging into a method versus trying to look inside a listener itself, because it gets a little bit messy and hard to trace. We then have our listeners an example of the actual helper method right here. So we have right here an updateDisplay method inside the action perform method. Now a listener, like I said, is just an interface. We just have to implement the required method. That means we type in action performed, not preformed or performed or act on or no. Action performed. Check your spelling more than once. And if you want to do some really cool stuff, this is a fantastic spot for the lambda notation, especially for refactored methods. Makes life really cool, simple, one-liners to handle all the listeners. It's a really clean way to do some great code, and we'll talk about that another time. We have a refactor method for updateDisplay. And so again, when a refactor method, what I do is I take code that I'm going to be using or calling multiple times, I refactor, I pull it into method so I can use it a lot better. And in this case, I have my updateDisplay where I call updateCount on my app data member. Then I set my background color to updateColor, which is a lovely random color. We've done a bunch. It's a lot of fun. And then finally, I do SampleLabel.setText. I grab the existing variable that we used already to grab that text value. I call my data member for my controller. I retrieve the value from that for that private data that I've been manipulating with the updateCount method, and then I add that to times using concatenation operator right there. And that way I can actually show that happening. And so that's the quick little thing for that. Now, we want to go and talk about the actual WindowBuilder tool, what we're using to make this stuff happen. And so as we can see right here, we have our Project Explorer, we have our Package Explorer on display. And to open the WindowBuilder, all you have to do is make sure the WindowBuilder tool is installed. You can do that with Add New Software inside Eclipse. Once you've got that, all you have to do is right-click on the JPanel or JFrame subclass, choose Open With, go down to WindowBuilder, choose the WindowBuilder editor, and click on it. You have a checkbox like that, and it changes the icon so it has a cute little J next to it. It's really great. You want to make sure you do your source tab editing first. Do all the code first, then layout afterwards, because it makes life so much easier to work with existing objects inside WindowBuilder. Trust me on this. So we have right here our WindowBuilder's design screen. By default, it has the palette open. Close it as soon as you can. It is not helpful. It will give you really bad code in worse places, so don't use it. Close it, make it gone, make it don't worry about it. On the top left section, we have our component pane. This is where we can see the hierarchy of all our components. If you're ever missing something, this is the first place to check. Make sure if it's in there. If it's not in there, you probably forgot to add something inside your setupPanel method. And so that's a really easy way to check to make sure you have all your components properly loaded. The bottom left corner is our properties pane. We're going to use that a lot, especially on our more advanced projects, because when you're talking about really complex properties, we really use that a lot. As you can see right here, there's nothing listed right there, but it's pretty empty. When you first use the spring layout, as you can see on the right-hand side of the editor screen, it's all squished up in the top left corner. Oh, that's not amazing. So we have to make sure we do some alignment and using stuff and use the springs to actually make that happen. So as you can see right here, I've added some constraints to that. We have the sample layout, we have the sample label is highlighted. So that's what I'm actually working with. You can see that I have some constraints listed down there in the properties section. That is 108 away from the west edge and negative 41 away from the north edge of the sample button. So it's above the sample button and 108 away from the edge of the west thing. And that's what we can see right there. And we can change those constraints manually right here inside the constraints section, or we can also change them in code inside the source tab. It's really great to get the basic idea, drag it around and use the WindowBuilder to do the basic structure, then do fine-tune alignment inside the source tab editing screen. Great stuff. Now, as you can see right here, I've focused in on the actual selection. We have our north and our west are our default constraints, and they're designated by the cute little dash blue lines, and they will drag around with that. And if you drag too far, like AKA off the screen, it's going to make it actually try and go backwards off the screen. So don't be silly. drag it and get the basic idea of where you want it, and then look at the values it gives you so you can figure out how you want to make that happen and make it work really nicely. And any values that you have loaded inside the constructor are automatically attached to the GUI components. So this is another reason why it's really amazing to actually use the WindowBuilder tool, because you can have everything predefined and ready to go, and you can see how your GUI layout is going to work inside your screen and have it do amazing things. Great stuff. Now let's go ahead and let's take a look at the actual app in action so we can see what's going to happen with this. So I'm going to go ahead and switch over to Eclipse. And as you can see right here, we've got all of our code. I'm going to go ahead and command run to run this app. And boom, here's my app. I can click on this frame right here and drag it around. As you can see, my app is right here and available for us. I can click the app as loaded. I've got the click me button, which is going to go and change my color randomly. And it also does the update right here to that data member that I've been sending to that. So if I take a look at the code over for this inside my little helper method, so I call app.updateCount every time I click it, then I set the background color to a random color, and then I retrieve that updated value, attach it to the text variable, and times, and updates the value right there. So it's really amazing stuff. Great little thing, wonderful setup, great system we can use. And so that's what we can actually do with this. Now I was going to show you also what happens if we don't use the Spring layout. So I'm going to go up here, I'm going to go ahead and take out this .setLayout, which is going to make it so that I have a default button. And in order to do that, I have it right there, save that, rerun it. And when I use a flow layout, everything gets set up like this. It just puts it up here in the top left corner, and it springs it so it holds it all together. And if you are just doing really basic things, that might be okay, but it looks really boring, and I don't want to do a boring looking app, so I want to do an amazing app. So we don't use the flow layout for that. So we'll go ahead and quit that out, uncomment out that lovely line, so we have our Spring layout being managed with that, and now my layout can be managed. Again, all I have to do to access that, I go over to the Design tab. As you can see, it rebuilds this, and if I drag this around, it adjusts the associated thing, so I have now those constraints change. I look over here, and like I said, it just dumped that code over here into my constructor. I don't want to have those applet constraint lines there, so I cut them out of here. And I'm going to take them all out of this section and move them down into the dumping ground method, aka the setupLayout. And I just put them all right there, save it, rerun it. And my app runs again, and it now looks the way I just told it to basically set up by using that. And so there's the click me right there happening. Because I use a Spring layout, now when I drag and move my screen, as you can see, my screen itself adjusts. The size right here of my label always stays the same specification away from that, as does my button away from the constraints it has. If I add more constraints to things, then the constraints will then be followed as well, so I can make things not move around as much. Or if we make it not resizable, we have different impacts. But that's the basic structure of how we can do some really cool things using the WindowBuilder structure, so we can do some really amazing apps and have some fun with that. So again, take a look at this. We'll go review the concepts that we have, but the amazing power that we have to do with this is we can use the WindowBuilder, using those tools and using the magic of the setupListeners method to attach those listeners to that. We can do some really great stuff and have some great times. If you want to do some more, take a look at some of the other videos and have a great day. Thanks. Bye.